This video is on wireless cryptographic protocols. Wired Equivalent Privacy Encryption Technology (WEP) was the first encryption protocol available to 802.11a and 802.11b devices before the WPA standard. Simply put, it was the first cryptographic protocol for a wireless network. It used RC4 stream cipher to encrypt the data. WEP had poor key management and didn't have any mechanism to renew keys. Also, it had no access point authentication, which enabled hackers to reroute data to access points through alternative unauthorized paths. This is why WPA was created, Wi-Fi protected access. Then was followed by WPA2 and 3. WPA original was the temporary solution that was made to replace WEP. The issue was that it still used RC4 stream cipher, which can be broken in minutes. However, it did add extra security protocol to the RC4 known as TKIP. TKIP is a protocol that employs 128-bit shared temporary key between the user and access points, and it distributes new temporary key every 10,000 packets, enhancing network security. This was still ineffective, and this is why WPA2 was created to replace it, which used strong AES-based encryption. AES is the latest symmetric key encryption protocol that employs 3 block ciphers, 128, 192, and 256. WPA2 also introduced counter mode with cipher block chaining message authentication code to replace TKIP. CCMP is a key feature in WPA2. Counter mode cipher block chaining message authentication code protocol uses CCM that combines CTR mode for data confidentiality and cipher block chaining message authentication code for authentication and integrity. CCM protects the integrity of both the MPDU data field and selected portion of IEEE 802.11 MPDU header. CCMP is based on AES processing and uses a 128-bit key and 128-bit block size. Then we have WPA3, which uses a more powerful and robust encryption by AES with GCMP, Galois Counter Mode Protocol. Unlike WPA2, it uses 192-bit encryption and it includes other features like simultaneous authentication of equals, as well as protected management frames and forward secrecy. SAE, simultaneous authentication of equals encryption, replaces the usual TKIP AES. This is critical since it eliminated problems with key reinstallation attacks, which was a problem for WPA2. SAE is a key feature in WPA3. All the features of WPA are 4-way handshake and authentication. Their built-in authentication allows access without password, and computers are authenticated against the radius with IP and keys provided automatically. 4-way handshake produces the encryption keys and message integrity checks. And message integrity checks adds few bytes to each packet to make them tamper-proof and uses hashing to prevent data modification.